But I was thinking to kick off the discussion with a question, and it's a very easy question that I think, if we can answer, we'll be sorted. So to people of the panel, what do you think is the biggest barrier to implementation of some of these industry 4.0 ideas across the formulation sector? Who?
I can answer in one word.
Yes.
Data.
Data, yeah.
Oh, yeah.
I'd agree with that, and the right kind of data.
Yeah, I mean, I would say, perhaps not surprising, given I referred to the that Maslow's hierarchy triangle a few times today. I think that for me, the data, the part of actually collecting the data and mangling and wrangling it into a point where it can be used. I think someone's already referred to the fact that there was one talk said, I think that they spent more time getting the data into form, where that was the hardest bit of the actual activity.
For us, I think apart from data is how can we have like an homogeneous implementation across the whole company, because it's such a big company. So you need to make sure that every time you implement a new system, that you get everyone trained, that people understand how to use it, what the benefits are. And whenever we upgrade systems, that we can update skills for the people working in R&D and also all different sectors, so that we have different departments that can access the same information. So we need to make sure that it's user-friendly for us and also for other departments. So I think it's been a difficult journey to try to make a lot of automation and digital to make sure that it works in terms of visualization for marketing teams and also for R&D, for example. So it's been challenging how to collect the data and also how to make it user-friendly and visualize it so that people that don't have those R&D skills or statistics skills can still make the most of the data and the information.
Also, I think that's a strong argument for selecting data formats that are very much open standards, and that's something that we've been Leah and I have been trying to push. So if you have a recommended basic concepts of data structures that capture the essential information, you can then allow other people to embellish it, as long as they can design their own data system so that they're completely compatible, and also nurture the development of an ecosystem of tools. So I personally represent a commercial company that's building tools that are not all free, but since the basis of this is encouraged to be open to everyone, we can satisfy the goals that you were just talking about. I mean, people can use the best tools that they can find or afford or whatever. Some of them will be more user-friendly than others. Others will be very technical. But everyone can still talk to each other, both inside the organization and outside. And even if the formats become obsolete, it can migrate into a newer and better form. It'll all be out in the open.
I think, really interesting on the data. I think actually, from our experience, we've seen there's lots of data out there, but it's about getting the value from that data. That's where the real challenge lies. I think as well, the two biggest challenges I see are one are on the business side of it. Like these projects take a long time, and often people want a really quick return for investment, and they're not up for the journey sometimes, which is a challenge. And I think someone mentioned earlier is skills as well. That's really, really key. We talk at a lot of events on digital manufacturing, and skills always comes up, but there's never really a lot done about it, I don't think. Or there's not enough action going on there. If you think about the rate that these digital technologies are changing manufacturing and the world, it's accelerating at such a speed. And places like us, Tom, at the universities, we just can't keep up with it. And training people to have these skills that they need for these factories of the future is going to take a long time. And I think there needs to be a lot more work in that area.
Yeah, I think that's clear. Skills is we can collect data, but people have to have the skills to use it. One question that's come in on the chat around the data is, is it the data type that's most important, or is it the quality or the quantity? can we deal with those different aspects of the data?
I guess I could take a crack at this one too. I think it's probably leaning towards quality. The data has to be designed for machine readability in mind. So you've got to be thinking about, I would say that the goal is to make sure that a relatively dumb computer algorithm can understand the information you've created as well as an expert scientist. And that's a lofty goal, but one does one's best. So if there's a whole bunch of stuff in there that can't really be interpreted by a simple script computer program, then it needs improvement. So starting with that as the basis is super, super important, because if you go and create vast quantities of data and there's a lot of ambiguity in there, you're not quite sure what this means or that means, then you might sort of just be wasting your time.
So I'd also echo that. I think it's also important that you have consistency within the data. Because if you're, for example, collecting data from the literature, people might use different experimental methods to measure something, and that will lead to inherent bias within the data, which makes it more difficult when you consolidate them afterwards and try and gain insight.
Right. So I think continuing the themes of easy questions. So defining the context, like parameters, assumptions of a model, can be as important as the data you put in. How can non-experts bypass this step in order to make use of expert tools?
I'll have a crack at that, especially because it's from Sam. But I think you need to. I think you need to partner with an expert. You can't do that alone. I think before I turned up with material science and things within our group, that was the prime focus of what the group did. It was really, my colleagues spent a lot of time collating data and then building tools to make it available to the relevant people. And you need to partner with an expert, and it's really important that the expert is amenable to listening. I think that's a key thing, to the non-expert and to the end user. And then you also probably at some point need to partner with IT, because they control the infrastructure that makes tools available to the non-experts. I think that's my experience.
Yeah, I think this needs to be thought about in the right way, because we say, so the question is about, if you go and want to build a model, then what do you have to do? Well, if you put yourself back in the sort of physical hardware world, and you want to build a piece of equipment, think about the people that you wouldn't expect as a bench scientist to go and be there operating the CAD equipment, and then converting that onto a lathe or a CNC milling platform, and then doing the electronics. So I think accepting that you need to be interfacing with the appropriate people. And Breanndán, I appreciate you were talking about you were trying to obviously build tools that can help and bypass that as much as possible. And I think that's very important, and I think there's very much a role for that to try to make that available. But I think also that process that Shyam just described, I think will always be required, where you have to. There's always going to be an element for talking with the data data experts.
I think there's another bit here on context as well, as in what is the prediction used for, and what does it mean, and what happens if the prediction is wrong. Because what's the saying? All models are wrong, but some are useful. And I think so. We've done work, for example, on allergen detection using machine learning and low-cost NIR sensors. Now, if you get that wrong, there's grave consequences in terms of food safety. Whereas some of our other projects where we're looking at food quality inspection, if you get something wrong and someone gets a cookie with 3 chocolate chips instead of 4 on it, it's not good for your business, but no one dies. So I think that's when you're looking at these predictive models, what are you actually using them for? Going back to the endpoint detection, if we get the mixing wrong by a few minutes, and it's it's a several hours mixing process. It's not the end of the world. So I think when you think of context, think of what you're going to use for it, and that's where it's going back to what I'm saying about the role of the human to take that model and interpret it. Because if you have got the predictive model system and it's a self-driving car crashing and killing someone scenario, isn't it? Whose fault is that? So I think you've got to be really careful around that as well.
I would say in terms of experiments, I agree that it's important to have someone that has expertise working closely, but sometimes you cannot have experts for every person on the bench doing experiments or every robotic platform. So we have experts that helps us develop systems to capture information and to build models, but as an experimentalist, you need to know which space to map when you're planning an experiment, for example. So we have a lot of training on design of experiments where we can understand first by scoping whether the space that we're studying in terms of formulations, for example, is hitting the performance standards that we want. And then once you define that space, then it's easier then to have enough data to create models or to see if the models can predict performance, for example. But it's important as an experimentalist that you know that you're working on the right space, because if you generate a lot of data in the wrong space outside of the parameters that you need, your models often cannot be extrapolated outside of that space. So at Unilever, we trained a lot on design of experiments, even for people that aren't aware of design of experiments. And we try to make sure that every team that is doing experiments and data analysis understands the importance of planning experimental designs on the bench or using robotic platforms, so that we generate data that it's useful rather than generating a lot of data that perhaps is outside of what we need or the models won't be able to predict outside of that space. Mm-hmm.
Also, the way it works in most industries is that the software tools get easier as they become more popular. I mean, companies and groups will start developing custom applications for specific areas, and they'll just get used more and more. They'll just become more suited for the specific tasks at hand. And also the similar kind of thing with data. I mean, right now, just from the stuff that I was just talking about, creating data pretty much from scratch, that's actually kind of tricky because no one else is doing it. But once pretty much everything you can buy or has been used before is already described in a machine readable way, you can probably just find it somewhere and just drag it into some user-friendly tool. And once people have done that a few dozen times, it'll just seem quite natural. So, if we just keep at it, it will become much more straightforward and normal to people.
So building on that, and and what Maria's saying now about training in particular aspects, and Nick mentioned before about skills. What do you think sort of chemists or engineers should do to adapt their skills to the new sort of digital future?
I would say quality by design and design of experiments is really important. Some basic statistics as well to make sure that the data that you're seeing is statistically significant, so that if you see a difference, it's making a difference. Yeah, so with that you can assess if your robotic or automation platform is actually giving you different results. You can also, for example, assess the differences between different people on the bench. So I can compare myself making experiments or measuring a response compared to a colleague doing the same experiment. So that gives you some insights as well. And I think flexibility, because as Alex was mentioning, specific teams try to build their own custom design or their own tool that helps them, but often companies move very quickly through different softwares to licenses, for example. So often you're used to a visualization tool or a design of experiments tool, and then companies' policy change and you have to then adapt and move from Tableau to Power BI or from Design Expert or Model to Jump platform. So you have to be able to quickly adapt and try to, maybe you won't become an expert in the new tools because they will be often changing, but try to adapt. And I think you learn a lot by just, clicking on the tool and trying yourself as well. So I think it's about adaptability as well.
Yeah, I'd add to that just what Maria just said. I think a message we could sort of give to our colleagues was don't be afraid of the. Because I think when we describe things as machine learning, or artificial intelligence, it can sound like this sort of huge monolithic body of mysterious knowledge that only certain high priests who are inducted into the temple can access. And when you start to break it down into individual techniques, and particularly at the so speaking personally, there's maybe the simpler end of machine learning. You're going to start to the PLS and principal components analysis and other thing, other sort of techniques like that. And you go, oh right, oh yeah, okay, yeah, all right. So and when once upon a time, design of experiment was, just picking up on what Maria was saying, I think design of experiment was quite a mystery to a lot of people, and again thought of this sort of magic voodoo. And yeah, again, I see now that's very much, it's almost used as as a standard tool. And so I think it's try and break it down, and it just, and maybe even introducing things to people, not using the machine learning. It's just a tool, a useful algorithm that helps you understand data.
Yeah, I think Tom, I think there's a lot. This is how we look at this, isn't there? I mean, I think you've got universities. I mean, we're both in engineering departments. We're looking more and more how we can bring data modeling into our curriculums, but it takes time for that to go through. I think there's also in work training. I mean, if you think about some of the things around data sciences, you can just go on Google, and there is a ton of free, wonderful data science courses that you can do online. So I think it's about companies enabling their staff to take this on and develop these skills, how they do that within their work environment. So I think there's lots of things around there, but I also think there's a bit about, it's really important that you do understand these. So I guess some of the applications, it's about working with those diverse teams with different skill sets, and the key for them to work effectively is all about communication. So when the data scientist is talking to the chemical engineer, they have some kind of common language, so they can talk about these problems and handle it. I think that's absolutely key, because the skills and development does take time. And as Mark was saying, don't be scared, get in there and try, because it's fun to do as well. There's some really interesting things you can look at there. And I think for all these digital technologies, the kind of chemical process engineering really is such an exciting area, and it's often not taken on these technologies as quickly as some of the more discrete manufacturing sectors. Some of the challenges we talked about before, but I think it's about organisations and individuals trying to have that growth mindset and work on this.
Yeah, and I think one of the things that in a lot of branches of science, the regular, more experimentally minded people need to get used to is that the data that they're generating really is a part of the report that they have to make. I mean, in my native field of chemistry, it's still, a lot of people think just making something that's equivalent to a dead tree and describing it as a narrative for another human to read, that's all they have to do, and there's no need to actually have a digital representation that works for machines as well as part of that output stream. I mean, it's happening, but it's taken a long time, and it's got a long way to go.
Yeah, so I think I agree, and I think that some of the things that is potentially, it's not necessarily for chemists or engineers to 100% solve these, but it's, I suppose it's having that tool set, so at least when we go and talk to someone, we at least understand the language that they're speaking. Yeah. We can still be the expert in the experiments or the formulation science, but so long as we can understand or talk to, say, a computer scientist, that's a big help. in the work. Yeah. There's so a question has come in that so are there many published formulation success stories of Industry 4.0 working that have shown worth that are understandable across sectors and disciplines?
I think the ones I've seen, there is some on kind of accelerating the formulation process by using data to explore the formulation space and just speed up that new product development or reformulation. I can't remember the precise examples. I think it might be one with an industrial project that's obviously might not be in the public domain, but I've seen quite a lot of people doing stuff in that. Yeah.
Yeah, there's definitely papers, especially in pharma industry, which was one of the industries that was the early adopters of design of experiments and using algorithms to predict, to quickly develop drugs for curing diseases. So you can see a lot of published information on using quality by design, as Nick was saying, to explain how they predict which will be the best. And often they use even genetic algorithms as well. So that's some success stories. There's some information as well from certain groups in universities collaborating with industry on machine learning as well. Especially also to be able to read data. So one of the comments was that when you're not generating the data and you want to gather published data to make sure that your data is robust or that you're capturing as much information as possible, often that data is not in a readable format so that it can be automatically read. So it's in PDFs, for example. So there's a lot of information as well. How can you capture data quickly through machine learning to classify it in a readable way? As Alex was saying, that computing can read it and then be able to then predict models based on that data.
There's a sort of a long question comment from Phil. Ryan, if you're happy, Phil, potentially to make a comment or ask verbally if you can, it might be easier than me reading out.
Yeah, thanks, Tom. Hi, everyone. Yeah, it was just a thought, really, just reflecting on some of the comments from earlier today. It was really understanding that there are, I think it was raised earlier, there are certain bits of kit that are not IoT4 ready, so to speak, and we can get only limited amount of data out for, specific processes. So, for older formulation rigs, etc. So what could be done as part of this community of practice? Maybe it's a challenge to see how we could work with suppliers to try and onboard them on the challenge, because as practitioners in the field, we are investing in new capital and kit. It's in our vested interest to try and have that metadata available to us so we can build and extend the value out of models that we're developing. And as a community, how could we align first in terms of understanding what those needs are and try and be congruent in what we're asking suppliers to do and making data available? Now, not every supplier will support it, but if we can sort of drive a direction on that, it might be helpful. It just adds value, I guess, in trying to standardize what we're doing. Yeah, just a thought. So discuss that if as a team.
I think absolutely, Phil. I think so. So one example, for example, is in the Material Innovation Factor in the open access flow that Unilever is using kit that belongs to the open access university flow. A lot of it is high throughput automation kit. We're struggling because some of our data capture systems are confidential. Yeah. So we're struggling to have a universal data capture system for each kit because some of the kits don't support the university data capture software, for example, or some of the kits, the company develops their own data capture, which is licensed only to that specific kit. So it's quite a challenge to be able to have just one universal platform for specific analytical kits. And it will solve a lot of problems, and it will be very, as a community, we could push towards a more homogeneous platform to capture data in specific analytical kits. That would be useful.
Yeah, I agree, Maria. I think maybe it's a job for this, after today, this community to pick it up and have an ongoing dialogue on how you best do that. to try and align the requirements that you then seek to work with partners or supplier organizations to get that data. That could be useful to input to model development and such like. So
Sure.
maybe that's the you know, the driving force for it. But I think, you know, I don't know if anybody else has got views as well or shared experiences of, you know, if you're lacking certain data, how can we access it? How can we make it available? The power of a community might be better than, you know, rather than just one key supplier, be it or one partner, small or large. Just a thought.
This is
one thing that we've seen that a lot of the time when sort of demonstrating value, it's very powerful if you can show sort of a demonstration of added value. Like, so when we worked with certain companies and we were able to sort of give them the iPad application and they were able to set up and deploy simulations and get results back in real time, it's quite powerful if you can kind of show them the value in that way. And as regards data sharing and things like that, you know, it's one thing for sort of like a company like IBM, which is really, when we work with a lot of collaborators, we're not really working in the same field, if that makes sense. So it's perhaps a little easier for us to sign the legal agreements to get data in order to build our pieces of work. But if you're looking at building standardized data formats and sort of ecosystem within a sector, I think pharma has made a lot of advances in that area, and perhaps there might be, because obviously companies are going to want to sort of be very careful about which data they sort of leak out into the community. Maybe sort of pre-competitive type consortiums working on some things where perhaps they're working on something that they sort of agree can be a standard but doesn't contain enough information in it in itself for it to be sort of valuable IP, if that makes sense.
Yeah, thanks, Breanndán. I appreciate things like open source type approaches, you know, the Plan S type of thinking here, rather than, because I appreciate that, you know, we're all different stages, different industries, different requirements and needs. You know, there's confidentiality, there's patents, there's, you know, IP, there's whole rafts of different outputs here on for different needs. So yeah, absolutely. Thanks.
Yeah, I was just going to add to that, but I think Breanndán kind of covered what I was going to go on about. We've done quite a lot about data-driven manufacturing, and when we go to the workshops, so the EPS last day, and we've done some stuff through Connected Everything, it seems like what's lacking is these real industry data sets. So academia, we can do some stuff in the lab and we can publish our papers and, oh, we've got a prediction accuracy of 99%, but it's lab work. We want to see this working on a real industrial example, but the challenge is people don't want to give data away if there is anything in there which is sensitive. And they've got massive security concerns over this. So there is a lot of work going on in trust, and there's some guys in Nottingham in computer science looking at this. How can we extract the data that we can use to build the models without giving away anything that gives an advantage to someone else? And yeah, these pre-competitive ones. I mean, I think it's looking at the challenges, isn't it? And understanding the case studies for a particular sector or applications. If there's something around sustainability, around safety, where there's a value to the whole community, no one wants to compete on things like food safety. Yeah. Everyone wants to get it right. So if we can look at examples where we can get a lot of the big players to say, actually, this is so important that we will play. They're not going to do it. I mean, the food companies differentiate on things like formulation, their ingredients, things like that. They're never going to share that, and that's fine. But I think if we find a few examples there, that's probably the way to do it.
Yeah, I agree there. Sounds sensible.
I think there's another question that I think is very linked to this, and you know, is kind of being touched upon lightly. Is that, you know, if I want to swap one digital formulation system to another, how compatible are these tools, and how well do they talk to each other? Can I transfer my data easily? And then a little follow-up of, is this something universities try? Well, Nick can maybe answer if you do where you are. I know, you know, we'll try and make something, you know, we get different systems, we'll make them talk to each other specifically to do an activity, but you know, I don't think we'll necessarily try different tools in this, and mainly because of cost to us. I don't know about you, Nick.
I guess this comes down to a word that I can never say: interoperability, I believe it is. And I think if we go back to, like, I remember years ago, it was the CAD problem. If you know, you build a CAD model, then you want to put it into some kind of discrete element model, and you had to mesh it, and then you get, and none of these softwares ever talk to each other. The CAD one wanted to use its meshing software, and it was a nightmare. Whereas what's happened, they've all gone, you know what? If we just have standard formats and people can move between, it's better for all of us, and that's what's happened in the CAD space. And I think this is, I think Alex or someone was talking about this earlier, this having these common ways of saving data and doing things, these common methods of using data lakes, for example, would be really useful and really good. So what can universities do? Compatibility. Yeah, I think it's challenging. I mean, we do stuff like that. We do lots of modeling. We've got these digital research services and things like that. So we can play around with data and stuff. But it just depends what you want to do with a particular application. Yeah, and have you got the right data?
Yeah, it's very tricky. And I heard open access, of course, mentioned earlier, which is one almost good way of making a format that is a consistent format as well, to allow these things to talk to each other.